Hi, this is another video to try to explain question number 5 because there are a few questions around question number 5 from multiple people, so I just thought maybe this one can use a little bit more explaining. So here we go. I'll try to explain this line by line, and here are the line numbers so we can refer to each line. Here's line 3. Line 3 is the declaration of a global variable integer, and this is pretty much the only reason why we should be using global variables, at least in this class, is for it to store a value that does not change over time. So in this case, array size is an integer value of 5 that does not change over time. As far as the compiler is concerned, every time it sees array size, it's kind of like seeing 5 itself. It's nice this way because otherwise I'll have to sprinkle 5 all throughout the program, and doing it this way means I can just refer to a single symbolic name. If I later on decide the array size should be different from 5, I can just change one line, which is line 3, and not having to worry about all of the other references to the symbol here. So I'll just kind of write down here a constant to be used throughout the program. Now, because this is actually used only within main, I could have used the definition or put the const definition inside main too, but it depends on whether it is used throughout the program. Alright, so now we have a structure definition, struct x, blah blah blah. This is just a structure definition, okay? So this is a structure definition like a cookie cutter. In other words, at this point we're not actually declaring anything that uses up memory. We're just defining the template of a struct x. It has two members. The first member is a character, so no big deal here. This is a character member named v. Okay. The other one is a little bit mysterious because it is a pointer. So this one is a pointer, and it is a pointer to a struct x, which makes it a little bit confusing because we are right in the middle of defining struct x. How can we have a pointer to point to something that is still being defined? Well, the answer is, oh, that's right. I used this analogy a little bit earlier today. So look at this. Okay, let me just write down first that this is an address, or also known as a pointer, to a struct x thing. Alright, so the way to understand this is, I'm pretty sure you have some envelopes in your house, right? Okay, so assuming that you have a few envelopes in your house, and it's about that time to send cards to people to remind them that you're still alive and kicking. So it's a good time to remind us of those things. So anyway, on an envelope you write down the address of another house, right? So it's about the same thing here. This is a struct x, which is kind of like a house, and inside the house we have one pointer, which is kind of like a label, an address label. And this particular address label is not the address of a garage, or the address of a doghouse, or the address of a warehouse. This is the address of a particular house, and that house turns out to be the same house that we're defining here. Okay, so that's why we can have a pointer to a structure that is actually still being defined, because a pointer is nothing more than just saying, okay, this is an address to find something like this, and this does not have to be fully defined because it's just a way to find another thing. So I'm hoping this helps to clarify the concept of why we can have a member inside the structure that is a pointer to that very same structure. Now, having said that, this is not okay. Okay, so let me just kind of write this here. If I have a struct x ABC here, this would not compile because you're now trying to build a house inside a house, and they are the same kind of a house, and that cannot happen because we're still in the process of defining struct x. So you definitely cannot include a member that is of the same structure that we are defining here. But a pointer is not an issue because we just need a way to find another thing that looks like this. So I'm definitely hoping this is going to be okay. Alright, so moving on to line 13. Line 13 is the declaration of an array. Now, when we see something like this, that is a combination of concepts, it is important for us not to just look at this and go, okay, this is something I haven't seen before, I'm going to give up. Okay, that's not, what we are supposed to do. What we're going to do is to look at this part here. Okay, we can recognize this part, struct x. Struct x is basically a structure that is user-defined, and it's basically the same thing as a type, kind of like int and char is a type. Okay, and on the other side we have a being the name of an array, and every time we see open square bracket and close end bracket, it means we're dealing with an array. So this basically is saying that a is an array of array size many items, and each item is a struct x. That's basically what it's saying. Okay, it is a combination of concepts that we have talked about in this class. It's a combination of array and structures, and basically in here also a local variable. But each one is somewhat orthogonal to the other ones, and they can be stacked up in this particular way. Line 14 doesn't need much explaining, but it's the same thing. You can see that the type is on the left hand side, the identifier is on the right hand side. On line 15, once again we have a combination of concepts. The first one is struct x itself, which is basically just a type. And then we have the asterisk here, which means we are now declaring a pointer, or you can call it an address to a struct x. And in this case, we have ptr as the name of the local variable, which is a pointer to struct x. Okay, at this point, I think it is good to clarify that it's not a typo. Okay, this local variable is called ptr, and this member inside the structure is also called ptr. There's no problem whatsoever, because there's no place in a program that we can confuse one with the other. The only time you can address, or the only time you can refer to a member inside the structure is using the dot notation. In other words, other than the definition of a structure, the only time you can use the name of a member of a structure is to the right hand side of a dot. Whereas with a variable, it cannot be on the right hand side of a dot because it is not a member, it is the name of a variable. So I'm gonna make this more clear a little bit later when we get to the line. Okay, line 17 is initialization. It is basically saying, okay, this is we need to go back a little bit. ptr is a local variable. It stores an address of a struct x. But whose address is it storing at this point on line 15? We don't know, because as a local variable, it is uninitialized. It's kind of like having a label, an address label that is uninitialized, except in this case it's not blank, it just has kind of random scribbling on it at this point, because you can consider all local variables in C and C++ as having random scribbling on it until you actually specify what the content should be. But this is definitely an address label. It is designed and made to store an address. Okay, except right now it's just storing it has some random scribbling on it. So what line 17 is doing is to initialize it. We can see that ptr is on the left hand side, so this is the one that is being changed. On the right hand side, we are referring to a. Now when we refer to a as a whole, it is the address of the entire array. And that's okay, because the address of the entire array is also the address of the first element of the array. And the first element of an array, in this particular case, is of type struct x. And guess what? ptr is also an address of a struct x. So the types actually work out in this case. If you put an ampersand here to the left hand side, so it becomes ampersand a, syntactically and meaning wise, they are acceptable, and they mean exactly the same thing as what we have here. In other words, when you're dealing with an array like a in this case, whether you specify the address of or not does not really matter when a is all by itself. Okay, but the what I just said does not apply when A is not all by itself. When you have indexing, then it doesn't work the same way. Okay. And then we have line 18 here. Line 18 is just the control part of a for loop. We are basically saying I goes from 0 because I controls the index of the element that we are accessing in array A. And this time we have I is less than array size minus 1, which basically means we are not using the entire array. We are leaving one element that is not used. Okay. And then we have plus plus I as the post operation. So after each iteration, plus plus I happens. And now let's go back. Let's go into the loop itself. Okay. So right here we have a local variable ch that is local to this particular scope from line 19 to line 24. So elsewhere of the program, they cannot access this particular local variable. On line 22, we are reading from the input stream standard input into a bracket I dot v. Now this is once again a combination of concepts. So once again we do it step by step. So we are not gonna be saying, oh, we haven't seen this combination before, we don't know how to handle it. Okay, because in programming a lot of times you will see concepts that you already are familiar with, but in combinations that you haven't seen before. So we have to kind of know how to stack the concepts and say, oh, okay, this is just a combination, no big deal. So we start with A. A is an array of struct X. Okay, and so the index operator is going to take care of the array part. So now we are not talking about an entire array. We are talking about a particular element with an index I. Okay, so what is the type of an element of array A? Well, from the definition, we know it is a struct X. So that means a bracket I close bracket is basically specifying a particular struct X. What can we do with a struct X? Well, because it's a structure, we can access its individual members using the dot notation. And that's what this dot is really about, is it is accessing a particular member of a structure. And which member are we accessing? It is the member called V, which is a single character. So that's how we can basically break apart something that looks a little bit long and kind of nasty because we haven't seen it before, into individual components that we have already seen and dealt with before. The next line, pretty much the same thing. Okay, the left-hand side is using the same thing as the as what we just talked about. A is an array of struct X, so a bracket I close bracket refers to element I of array A, which turns out to be a struct X because it is an array of struct X. The dot notation means we are accessing a particular member of a structure, and this time we are accessing the PTR pointer member of the structure. So this entire side is basically saying, we are accessing the PTR member of element I of A. I know, when we say it in English, we're actually talking backwards because we are saying we're accessing member PTR of element I of array A. So it's just a little bit opposite because we use the preposition of in this case. And this whole thing is a pointer. It is an address to a struct X. So this is a good time to pause and say, okay, but how do we know this is not referring to the local variable PTR that we declare on line 15? Well, that's because when we are dealing with something on the right-hand side of a dot notation, it cannot be a local variable. It has to refer to the name of a member of a structure. So that's why we know this is not referring to local variable PTR, but referring to member PTR of whatever structure is specified on the left-hand side of the dot notation. Okay, so now that we have the left-hand side dealt with, let's deal with the right-hand side, because the right-hand side is kind of mysterious too, because we know what ampersand is. It is taking the address of something. We talked about this when we talked about scanf. And we also know the bracket notation. It is for accessing a particular member of a structure, of an array. So in this case, what is important is the order of the operators. And in the final exam, if you are not sure about the order or the priority of operators, you can always ask me. So if I use parentheses to clearly indicate the ordering of the operators, this would be it. Okay. So we are now referring to the address of, okay, this is on the outside, this is the last thing that we do, taking the address of something. Whose address are we taking? Well, let's take a look at the inside, right? We're taking the address of not the entire array A, but element I plus 1 of array A. In other words, we're taking the address of the next element, the element next to A bracket I, and say, oh, you know what? That address, that element's address, is now going to be stored in this particular element's PTR member. That's basically what we are talking about. If you really want to visualize this, you can kind of look at the array as a street, one side of a street, let's just say, okay, and it has houses. We are basically saying each house has a address label of the address of the house next to it. That's basically what it is. So if on the street we have, let's say, John's house, Joe's house, and Jim's house, okay, that means, the first house is John's house. Inside John's house is an address label, and the address label has the address of, who's the second one? Joe's house. And then inside Joe's house, which is the second house of the street, there's an address label with the address of Jim's house in it. Now the question is, what is Jim's house having as the address of? So in this case, Jim's house has an address of a null, which is basically, because it's the last item of the entire array, it has a null pointer, which basically means it is not storing anyone's address. It is also a good time to kind of go through this and kind of think about how many of these elements are actually storing a character read from cin. Remember, array size is 5. So I is staying in, we're staying in the loop as long as I is less than 4, which means when we go through the body here from line 20 to line 23, I is going to have a value from 0 all the way up to only 3. So 0, 1, 2, 3. There are 4 elements in the array that will have the v member initialized, as well as the .ptr member initialized. By the time we get out of the loop here, I is going to be 4, because that's the first value that is not less than 4. So by the time we get to line 25, I has a value of 4. And this means the last element of the entire array only has member PTR initialized to a 0, which typically means don't follow this pointer, because it is basically, think of this as a blank address label. It's just saying, okay, this is not a real address. Do not go there. Do not follow this address. But this particular element of A does not have the .v member initialized. So just kind of keep that in mind. I know this for this particular program, it is not what it's asking, but we really only have 4 characters read from cin in this case. Let's take a look at line 26, which is probably one of the most difficult part of this entire program. And I already wrote down the comments here about how to decode it, but it doesn't hurt to do it again. And this time we'll definitely do it step by step and try to figure out what it does. It's really just like when you're evaluating any expression with using parentheses. You have to figure out what is inside what is the innermost portion first before you work your way out. So for the innermost part is this PTR here. Is it to the right hand side of a dot notation? Nope, it is not to the right hand side of a dot notation. So that means we are referring to local variable PTR, okay, which is a pointer to a struct X. What can we do to a pointer? Well, we can initialize, we can store an address in it, or we can also dereference it. So this is the dereference operator working on PTR, which is basically saying, okay, I'm not interested in the address, I'm interested in what is at that address. So when you look at the highlighted part here, it is no longer referring to the address of array A. It is now referring to the element, the first element of the entire array A, which is this part here. Okay, so this here is referring to a bracket 0, not the address of a bracket 0, but a bracket 0 itself. Now a bracket 0 itself is the first element of the entire array. What is the type of an element in array A? Well, it is a struct X. So that means this whole thing is a struct X. What can we do with a structure? We can do several things. We can take the address of that thing. We can also access individual members. So when you look at the next thing that we are doing, which is .ptr, that is being applied to this portion here. So .ptr is basically saying I want to access the member called ptr of, well, of whom? Well, of whatever is to the left-hand side of the dot notation, which is a bracket 0 effectively. So now we can see that this is basically saying the ptr member of a bracket 0. Now if you remember what we talked about earlier, the ptr member of a bracket 0 contains the address of a bracket 1, the house next door, right? So that is basically, the highlighted part here is the address of a bracket 1, which is the second element of array A. What can we do with an address? We cannot do a dot notation with an address. Okay, that's not allowed. But that's not what we're doing here, because when you look at the parentheses, I did not actually use the right highlighting. There we go. When you look at this whole thing, the dot v is actually not doable, not applied to the highlighted portion here, but the asterisk is. So the asterisk basically is doing dereferencing again. The highlighted portion from here to here is referring to the address of the second element of array A. And what can we do with an address? What can we do with a pointer? Well, we can dereference. Let's follow that pointer and see where it leads us, right? So that's what this expression is it is dereferencing the address of the second element of the entire array. When you dereference the address of something, you're just basically talking about that something, which in this case is the second element of the array, or otherwise known as a bracket 1. A bracket 1 is of type struct X because A is an array of struct X, so each element has the type of a struct X. What can we do with a struct X? Well, it has two members and we can access the members, right? In this case, we're only accessing the .v member, which is the char. And so this entire expression basically is referring to the .v member of the second element of the entire array. Now, if I want to look at this entire expression and just spell it out in English, it's going to be something like this, which is not going to be very helpful because it can be just confusing a little bit. So we are accessing the member v of whatever is pointed to by the ptr member of the structure pointed to by ptr. That's how you say the entire thing. Let me say that one more time. In fact, I'm gonna write it down here just so that you have a visual cue as well. Okay, so this entire expression goes like this. We are accessing member v, which is the .v notation, of whatever is pointed to by, which is the asterisk symbol. Okay, member v of whatever is pointed to by the ptr member of, which is the .ptr notation. And then once again, we go back to whatever is pointed to by, which is the other asterisk symbol here, and here local variable ptr, which is the one in the innermost part. Okay, so that's basically how we spell out this whole thing in English, and I'm not even good at that. Okay, and let me just double check this is correct. Okay, we are accessing the member v of whatever is pointed to by the ptr member of whatever is pointed to by local variable ptr. Okay, so that all works out. The notation is not exactly the easiest to understand because because some of the operators, like a dot notation, is what we call left associative. Okay, and it goes between two things. And other things like the asterisk symbol is a what we call a unary operator, and it appears on the left hand side of an expression. So that really definitely does not help to make things easy to understand. But having the extra parentheses, definitely kind of counters that, because it helps us understand this is the first thing we access, this is the next thing that we do, this is the next thing that we do, this is the next thing that we do, and this is the last thing that we do. So that's why we have these extra parentheses here. Now just remember, in the final exam, if you're not sure about the order of operation, I can help you by giving you extra parentheses if I forget to specify extra parentheses. But I cannot tell you the exact order like what I just did here. Okay, I cannot tell you do this first, do that next, and so on. I can just tell you, okay, what you're looking at is equivalent to this expression here with extra parentheses. That's the best I can do during the final exam. Alright, so I'm hoping this little video, which is taking about 26-27 minutes, is helping you out, at least understanding question number 5. And all of these concepts are not really just here because TAC just wants to ask some really obscure stuff about C and C++ for the final exam. This is actual stuff that you will see in C and C++ programs out there. These are considered fairly basic expressions in C and C++ programming, especially when arrays and structures and pointers are involved, which is a lot of times. Those concepts tend to be used in conjunction a lot of times. So I'm just kind of hoping that this will help you with all your future C and C++ programming. Alright, so I'm going to stop the video now exactly at 27 minutes.